Hello everyone, my name is Zhanhong from Xiamen University in China. Today, I will present our paper When Data Sync Means Message Locked Encryption, a feature-based data sync scheme for encrypted cloud storage. We will talk about it in several aspects. In recent years, the demand for cloud storage is growing. In terms of the usage of cloud storage, file sharing and collaboration continue to be the category with the greatest variety of cloud services in use. The data sync is a primary and critical technique for cloud storage services. Let's talk about the existing cloud sync schemes. A full sync scheme syncs the whole file no matter how many changes are made to the file, whereas in a data sync scheme, only the changes made to the file are synced to significantly reduce network transmission, which explains why it is much more preferred in recent studies. Currently, to resist unauthorized access to the user's files, files are suggested to be encrypted before being uploaded to the cloud. However, when users use their private keys to encrypt files, the same content will be encrypted into different ciphertexts. Recently, a new cryptographic primitive named message locked encryption is proposed. It derives the secret key based on the file content, such that the identical files can still be encrypted into identical ciphertext files. However, files using message locked encryption method encounter challenges in data sync. This figure shows that a small modification can lead to a large number of encryptions during data sync due to key change. Our preliminary results show that with the increasing of data set size and the insertion times, the phenomenon of data amplification will become more serious. This is caused by the change of the key, which motivates us to think how to guarantee the stability of the key and avoid data amplification. Based on the observations, we propose a feature-based cloud sync scheme, Feature Sync, which encrypts files based on their features to achieve data sync efficiently. Moreover, Feature Sync further merges one batch of requests to eliminate network round trip overhead. This figure shows a system architecture of Feature Sync. It has two main functional mergers, Feature Search and Encryption merger, File Package and Granularity Select merger. Feature Search and Encryption merger has two main tasks. Firstly, it will scan the entire file byte by byte with a sliding window. In the process, it calculates the fingerprint value of each window. When the fingerprint of a window is larger than the feature value, the feature value will be refreshed. After the whole file is scanned, the feature value obtained is the feature of the file. Then it uses the feature as a key to encrypt all chunks in the file. Compared with the directly calculated hash, the feature of the file has better stability and will not be easily changed due to a small modification. As we can see, regardless of data sync and full sync, both methods need several network round trips to complete a sync request. In a high-latency network environment, the network round-trip overhead caused by a large number of requests is undoubtedly a heavy burden. We try to combine the same batch of requests by package, so as to reduce the number of network round trips to a fixed 4. In addition, we will dynamically select the granularity of the sliding window according to the properties of these requests. Our sync process is shown in the figure. Firstly, client pretreatment files, including packaging and encryption. Then, client sends the sync request and the selected window size to the server. Server divided the old file into chunks according to the window size and calculates the checksum, and send the checksum list back to the client. Client sends the data data to the server by comparing the checksum, and finally build new file on the server. We implement a high-weight prototype of feature sync on top of the async open source code on GitHub. We built the client and the server on two Aliyun cloud servers as our experimental platform. This is the dataset we use. Because other existing sync schemes do not support encryption, we use two different trunking methods to encrypt the file, and then use sync tools. We also use packaging for other schemes and chose the same window size as feature sync to ensure fairness. This figure shows that the sync time of feature sync is much lower than other schemes. In order to clarify the reasons, we carry out more analysis. By breaking down the composition of sync time, we can see that feature sync spends much more time on pretreatment files than the other schemes because feature sync need to search feature, but the impact on sync performance is small. The bottleneck of sync time is mainly on the network. By observing the network traffic, we can see that the key to reduce the sync time of feature sync is to reduce network traffic onto the feature-based encryption, which avoids the data amplification to a large extent. More tests are in the paper. Okay, let me conclude the paper. First, message locket encryption may cause data sync failure due to the key change. Second, feature sync carefully selects feature within a file as the key for file encryption, thus supporting data sync efficiently. Okay, that's all, and I would like to take questions. Thanks.